Hi, I'm Andrew Connell, and I'm a Microsoft MVP in the area of Microsoft 365 development. And I have a lot of experience with SharePoint development, including all of the different development models that we've had, Microsoft Graph development, Microsoft Teams development, and developing add-ins for Microsoft Office, as well as working with Microsoft Identity, including Azure AD. Many solutions involve creating web APIs to expose functionality to different clients and consumers. Developers can secure these APIs using Microsoft Identity to ensure only approved apps can access the web APIs that they've been granted the necessary permissions. In this module, you'll learn how to secure a web API with Microsoft Identity and how to call it from another application. In this unit specifically, we're going to learn about how to register an Azure AD application to use in securing a custom API. Microsoft Identity can be used to secure a custom web API so that only authenticated users and applications can access it. You can use custom APIs to expose the line of business applications and systems that should be protected with a trustworthy identity platform such as Microsoft Identity. Once an API has been secure with Microsoft Identity, you can enable users and apps to authenticate and access the web APIs through many different types of applications, including desktop, mobile, web, and services or daemons. The Microsoft Identity Platform is a great solution for securing APIs, especially when your users and their data are secured with Microsoft Identity. For example, consider the scenario where a company in Office 365 sells categories of products to their consumers. Your inventory management system needs to allow certain employees read-only access to products while others can create, edit, and discontinue products. The inventory management system can be developed to leverage multiple APIs, from custom APIs to manage the product's inventory to Microsoft Graph to look up different employees. Another option is to create a custom domain-specific web API that abstracts the calls to these different APIs and line of business systems from the inventory management system developers. The custom web API should be secured and only grant some users limited permissions while other users can perform more privileged actions. Let's look at how we can plan secure web APIs. When securing an app with Microsoft Identity, you need to think about who will access the app. Will the users of your application be employees in your tenancy, partners in a business-to-business scenario, or customers in a business-to-customer scenario? Or is the primary use case one where you've created a web API secured using Microsoft Identity that's primarily called by other applications? In this module, we're focusing on the last option in the figure above, terminators. A terminator is an application or a service that communicates with your custom web API secured using Microsoft Identity. There are two types of terminator applications, one that acts on behalf of a user and one that acts on behalf of itself. In the first option, on behalf of, is when your user authenticates and uses an application that will then make a request on behalf of the user to the secured web API. In the second option, the application acts as a service or a daemon where there's no user interaction. And in this case, the app acts as itself. Daemon apps authenticate with Microsoft Identity to obtain an access token and include the token in the authorization header value of each HTTP request to the web API. But before you can build applications that implement either the on behalf of or the daemon scenario, you must first create and secure the web API. Securing a web API with Microsoft Identity that can be called by other applications involves two main tasks. You're first going to register and configure the Azure AD application, and that can be done in the Azure AD Admin Center. Then you're going to code the web API project, and you're going to configure it to support Microsoft Identity. The first step is to register the app in Azure AD using the Azure AD Admin Center located at https://aad.portal.azure.com. Once the app is registered, you can then define the delegated permissions that are also called scopes to your that your API exposes. Then you will write the business logic within your web API to determine what is allowed or prohibited based on the scopes and user identity listed in the access token that's received in the HTTP request. Each scope has a name and a description property for the user consent and admin consent. User consent is when a user grants an app permission to act on their behalf, while the admin consent is when a global tenant admin grants the permission on behalf of all users or an application. After registering the app in Azure AD Admin Center, make a copy of the tenant ID and the client ID of the app. You're going to need these values when you create and configure the Web API project. Microsoft Identity only returns blobs of text as access tokens. Your API should always validate the access tokens and ensure that they were provided by Microsoft Identity. Access tokens are signed with a private key, and you can verify their authenticity with the matching public key. Microsoft Identity provides libraries and middleware available for most platforms that are going to simplify this process. Your custom API should also enforce permissions using scopes included in the provided access tokens. Delegated permissions should never exceed what the signed-in user is allowed to do. What you're going to do is you're going to use the existing startup.cs file that you get in a ASP.NET Core Web API project to configure the authentication settings for the Web API. Update the configure services method in the startup class in the root of the project to contain the code that you see here on the slide. In this code, the options object is initialized by loading the project's app-settings.json file. This file contains properties for the Azure AD registered app's tenant ID and client ID. When you create the controllers or the endpoints for your Web API, you'll also need to make sure that the current request has the necessary permissions or scopes granted to it. This can be done using a static class that contains a single method. The following scope validator class has a method called verify user has any accepted scope that will check if the current request will check to see if the current request's included access token contains a specified scope. It's going to give you a Boolean value back if the desired scope is not present. This new method that's added to the current HTTP context is used within your controller's methods to first verify the current request includes the necessary permissions. If it doesn't, it'll throw an error. Otherwise, it'll continue and execute the desired result. In this demo, we're going to see how to create a ASP.NET Core Web API and secure it with Microsoft Identity. Now, the first step that we're going to need to, before we go create and work on our code project, is we're going to have to register an Azure AD app inside of Azure Active Directory. So what I've done is I've logged into my Azure Active Directory Admin Center, which you can locate or you can visit at aad.portal.azure.com and signing in with your account. So what I'm going to do is I'm going to come over to Azure AD and I'm going to select App Registrations and then select a new registration. Now from here I'm going to give my app a name of Product Catalog API, and I'm going to use just my single tenant option, but you have a couple different account types that are supported. So I go ahead and select register, and then I'm going to select the expose an API. Now we're going to add a scope for the API, so I'm going to select add a scope. It's going to ask me for my application ID URI, and in this case here I'm going to go ahead and just leave it selected as the default and hit save and continue. Now, the next piece that we're going to do is I'm going to add a scope. So this is giving me an option to add a scope here. So I'm going to go ahead and add a scope of products or product.read. I'm going to say it's available for admins and users. The name for the admin consent is going to be read product information. And the description is going to be allows the app to read product information. The user consent, this is read product information, and this will be allows the app to read product information. I misspelled information, let's fix that. Okay, so this scope here, we have an admin consent scope and a user consent scope. So this scope that I've listed here for product.read, when I say admins and users, this means it's a delegated scope. And it also means that not only can the user grant this permission to the app or to their app that is requesting it, but so can an administrator. They can also grant consent to everybody in the organization for on behalf of all those users, so they don't have to each individually add that. Admin only consent. This says that is not that users can't grant this permission. That only an admin is going to be able to grant that permission. So then I'm going to select Add Scope to go ahead and add the scope. Now I'm going to do the exact same thing to add another scope here for product.write. And I'm going to pick all of the same options here. So I'll do product.write. Let's see, let's make this be called admins and users. And we'll say write product information. Write product information. We'll just select all that, and then it'll be write product information. It's basically the exact same thing that we have for both of them. You may want to say something different, depending on who's granting the permission. But in this case here, I'm just using the same thing for everything. I'll also do one for category .read. This will also be admins and users, and I'll give this one a read category information. We're going to use the same name in both of them, and this will be allows the app to read category information. Again, we'll grab that, paste it over here, put a period on the end of each one of them. All right, so now we have three scopes that we've defined. These are both these are all three delegated permissions. I'm going to add another one for an administrator that requires administrative consent. So this one's going to be called the category.write. Only admins are going to be able to create this, to create or edit existing categories. So this one will be called write product category information. Let's scroll down a little bit. And then I'll have allows the app to write product category information. Now, I'm not going to enter in a user consent because we said users can't do it. So I'm just going to leave that blank. And I'm also going to mark that one as enabled. And we'll go ahead and add that scope. All right, so my app has now been set up. We got all of our scopes defined for our app as well. Let's go over to our project in VS Code and see what we have here. Now, I went ahead and I created this .NET Core Web API application using the .NET Web API or the .NET command line tool. So I just typed in .NET new Web API. I said the name of it is product catalog. And the AU, I said, is single org. And what that means is I wanted to set this application up or this Web API up for not being multi-tenant. I only want it to be a single tenant. All right. So let's take a look at a couple things that I've done within this project. So a few things that I've done. One of the first things we have to do with our project is I have to configure the project to request authentication and bearer token validation. So it's pre-configured to authenticate the request using the HTTP request authorization header. So what I've done is if I come over here into the startup.cs file, and if we find the configure services method that you see here, what I've added is I've added in authentication for Azure AD using the bearer authentication scheme. That's where we have authorization with the value of bearer space and an OAuth token. And then I'm also going to go in and I'm saying to configure the options for my add Azure AD bearer configuration or scheme. I'm setting those options and I'm binding those options to the Azure AD options object. Now, what this is going to do is this is going to read information from my app settings file for my project. That's just the way the .NET Core works. So here you can see I've got a couple different values that are all set up here. So I have tenant ID and client ID. I'm going to go ahead and grab these values for tenant ID and client ID. I'm going to grab them from my app that I created in Azure AD. So we have our directory or tenant ID. Let's copy that. And I'll come over to my application and I'll paste that in here. And then I'll also do the same thing for the client ID. And so what that's going to do is that's going to associate this code project with the app that I created in Azure AD. Now, the next thing that we did is I added in a new import statement to the Microsoft.asp.NET Core.authentication or authentication.jwt bearer. Now, what this is going to do is this is going to update the configuration of the middleware for the Azure AD bearer middleware. So in the configure services that we see right here, after I've added that to modify my settings, I then am going in and I'm setting up services here. So I'm setting up a service, I'm configuring this with the bearer options, and I'm setting up to the bearer authentication scheme, and I'm telling it where to go find everything about the application. So notice here that when it goes through and it tries to validate the audiences, it's checking for the audience and it's checking for my API as an audience as well that's going to get updated. That audience property is coming from this options object, which is being derived from the client ID property inside of app settings that you see listed right here. Now, while the provided middleware is going to validate the token, authorizing requests for a specific controller action is the responsibility of the developer's responsibility of me. So in this demo, the presence of a scope in the token, we're going to use that to authorize a specific action. So if the scope is present in the access token in the request that's made, then the action is going to be allowed. So what I'm going to do is I'm going to create this file here called the scope validator. And what this is doing here is you can see that it's a static class that's been defined and a static method that's defining on it called verify user has any accepted scope. And I'm passing in the HTTP context. So what that's doing is that's going to add effectively and extending the HTTP context and adding on this method to that context. And this is going to then pass in all of the accepted scopes. So what this code is going to do is it's going to look at the authorization token or access code that is provided by the request, and it's going to look for the presence of any of these scopes to tell me if those are present in the request. So if I specify that I need category.read, it's going to make sure that category.read is a scope inside of that request. Now, by convention, the ASP.NET Core Web API projects store model classes in a folder called models. So here's my models over here. And I've created two models. I've got one for products. So my product has an ID, a name, and a category. And then I've got a category object, which just has an ID and a name. Now we're going to store our sample data. I'm going to store it in memory while the app is running. And the data is going to be randomly generated when the app is started using a NuGet package. So it's going to do all this stuff kind of for me, which is a cool little thing that, that we're going to be able to do here. So what I did is I added a package called Bogus, a .NET NuGet package called Bogus that you see listed right here. And I'm then going to create this thing called sample data that is importing that Bogus class here. And you can see that when in my sample data that has a collection of products and categories, when it initializes, it's going to populate it with a bunch of bogus data. So you see here I have this this faker object that's getting imported. Well, that's part of the bogus package. Now the sample data is stored as a singleton using the dependency injection container that was built into the ASP.NET Core. And we can set that up if I come over to startup.cs. And if I look inside the configure services here, you can see that I'm adding a singleton for my sample data. And so that's going to go through and add in my sample data to my application. It's giving me like my in-memory database. So now the next thing I have to do is I need to go create a controller. So my controllers is how my API is going to end up working. So for example, I have a categories controller. Now, notice here that I'm using this authorize attribute. So the authorize attribute forces the request to have a valid authorization header in the request. Each of the actions methods are going to make a call that we're going to use to verify that it has the specific scopes that we've defined. So in this case here, this authorize request, as you see when I say get all categories, it's going to make sure that the current user has the scope of category.read in the request, or the current request has that scope. If it doesn't, it's going to throw an error. So if it does, it just goes on to the next line, which is going to return back all my categories. Same thing a little bit farther down. I'm doing an HTTP GET for a specific category. Make sure we're allowed to do that. But notice here, for this one, this is an HTTP post. I'm creating a category and I'm checking to make sure that someone has the category.write or the request has the category.write. The product catalog, well, it's going to do the exact same thing. Let's go over here. The product catalog is doing basically the exact same thing. I can get a list of all products, get a single product, or I can create a product. And notice that product.write, product.read, that's how I'm doing all of my error checking. So at this point here, I've got my web API that's been secured with Microsoft Identity. And in the other demos that I'm going to show you throughout this module, we're going to go build some apps that are going to use this secure API. But before we can really test it to see it work, we really need an app that's going to be able to go grab the token. So let's go jump onto the next section and talk a little bit about creating web apps. And furthermore, we're going to look at creating a service that can do this as well. In this unit, you're going to learn how to create a server-side web app that will enable users to sign in and grant the app permissions to act on the user's behalf. Now let's see how to create and configure a web API so that it can be accessed and secured, a web API on behalf of a signed-in user. The first step is to register a new Azure AD app in the Azure AD Admin Center that will represent the web application. The important part of the app registration is that the creation of the app secret. This secret, along with the client ID of the app, is used by the web application to authenticate with Microsoft Identity when it requests an access token on behalf of the signed-in user. Web apps that call web APIs are confidential client applications, and that's why they register a secret, an application password or certificate, with Azure AD. The next step is to create the web application that will allow the user to sign in and then access the secured web API. Create a new ASP.NET Core MVC application using the following command, followed by installing a few NuGet packages to support Microsoft Identity. Now update the project to associate it with Azure AD app that you registered for the web app. You're going to open up the app settings.json file, and you're going to set the details of the registered Azure AD application that you previously created, setting things like the domain, which is the domain of your Azure AD tenant where you registered the Azure AD app, the tenant ID, which is the ID of your Azure AD tenant where you registered the app, and then the client ID and client secret, which are the ID and the secret for the Azure AD app that you registered. Next, configure the web app's authentication by updating the configure services method in the startup class for the project. First, configure the web app to support authentication with Microsoft Identity using the details from the app settings.json file. And you see that here where I'm creating a confidential client application. Then configure the app's services to support the user signing in to Azure AD and providing an authorization code to the web app. The web app takes this authorization code and exchanges it for an access token using the Azure AD token issuing endpoint. The next step is to create controllers to implement the pages on the site. When the user requests one of these pages, the web app already has an access token for the user. The token is used in addition to the web app's Azure AD app details to obtain a new access token. And the resulting access token is intended to be used with the web API, but is for the web app to use. Each controller's method representing a page can then use this getTokenForUser method to issue a request to the web API with this new access token. In this demo, we're going to learn how to create a server-side web app that is going to enable users to sign in and grant the app permissions to act on the user's behalf. Now, once the user is authenticated and granted the app consent to act on their behalf, the web application is going to use the data returned from a secure web API by using the OAuth2 auth code grant flow. Now, this is going to assume that we created the secure API app registration in the Azure AD Admin Center and the associated project from the first demo that I've already gone through. This demo is all going to be about creating a web app that consumes that application or that API. So the first thing we have to do is we're going to have to create a new Azure AD app that is going to be used by our web application. So I'm going to do that by going to Azure AD. I've already logged into my Azure AD admin center by going to aadportalazure.com. And I'm going to select app registrations and then select new registration. Now the app we're going to create here is going to be called the product catalog web app. And I'm going to leave it as a single tenant app. We're not going to deal with multi-tenant in this case. And on this page here, one of the things we're going to need is I'm going to need my client ID and my directory ID. Okay, I'm going to get that stuff in just a few minutes though. I don't need to grab that just yet. But over here, I'm also going to select my get a redirect URI. Now on this page, on the authentication page, you can see this took me over here to the authentication page. What we're going to do is we're going to add a new platform. So let's select add a platform, and then we're going to select web. Now on the configure web, we're going to set up our redirect URIs and our logout URL. So I'm going to use HTTPS localhost, and our application is going to run on the 5001/signin.oidc, and that's the endpoint that's generally used by the OpenID Connect middleware that we're going to use in our ASP.NET Core web app. So our sign out or our logout URL is going to be the sign out OIDC link as well. Now a little bit farther down on the implicit grant, I'm going to select access tokens and ID tokens to make sure that those are going to be provided to me, and then I'm going to select configure. Now the last thing we're going to do is I'm going to come over here to the clients and secrets tab, and I'm going to create a new client secret for my app. And I'll go ahead and just select add. I didn't give it a name. Now I need to grab this value because we're going to use this in the application. So before I navigate off this page, because once I navigate off of it, we're never going to see this again. So if I switch over to over to VS Code, I have my old ASP.NET Web API project that we created in Demo 1 off in the background, and I have this new web app that I've created over here that we're going to walk through. The first thing we're going to do is I'm going to go ahead and configure this. So a few things we want to configure. I need to set up the tenant ID, client ID, and the secret. So I'm going to go grab the secret, and I'm going to paste that in right here. I'm going to go grab the client ID, and that's going to be over on the overview page. So here's my client ID right here. And then I need my tenant ID, which will be the same tenant ID that we had when we did the previous demo, because they're both in the same directory. Now I've also added in, after I created this project, I've also added in a few other things here. I've added in references to things like the Microsoft Identity and the extensions configuration. These two, Microsoft Identity, that's the MSAL library, and configuration is also going to be used by going to our extended configuration. We actually forgot one thing over in the settings, and I think about it, I need this qualified domain name. I need to update this for Azure AD. So if I come back over here to my app, I can find that if I go to my dashboard for my directory, and there it is right there. So I just need to grab this value right here, this domain for my directory. This is the domain for my Azure AD tenant. Now, the next thing we want to do is we want to configure the web API information. So the web app's got to know the URL and scopes that are required by the web API application that we created in the previous demo. And the scopes that are defined in the web API are found in the expose API blade of the app registration and the Azure AD portal. We already saw that because we created that in the previous demo. So what I need to do is I've created this constants file here. And what this constants file is going to be used for is I'm using this to define where my API is for those different endpoints and a list of all the different scopes that are available to it as well. I've also defined the claim IDs for the user object and for my tenant over here, down here, as well as different things that we're going to use in our project in a little bit in a minute. So now I need to configure the middleware for my web app. So I've added in a handful of using statements. I've got ASP.NET Core OpenID Connect right here. I've added in the identity model OpenID Connect right here. Also added in Microsoft Identity.Client and security claims, which are up here. Now, the next thing we're going to do is I need to go through and I need to configure the services. So what I'm doing here under configure services is I'm adding in, as we did previously, I'm adding in authentication using the authentication scheme, and I'm binding it to the Azure AD property in our configuration file. I'm then going through and loading those settings, and I'm going to bind those settings, these Azure AD settings, I'm going to bind them also to Azure AD because there's some other properties we need to fetch out of this. Then we're going to create a confidential client, and the confidential client is used when you have an application that you can protect the secret. For example, you would not use a confidential client. You would use a public client in the case of mobile apps or for our native apps. So you can see I'm defining it with the authority, a redirect URI, and with a secret, and then I'm going ahead and adding that to my application. And then the rest of this registration stuff that you see here, all is just standard. How do I configure ASP.NET Core for Azure AD authentication? All right, so this is just doing all the standard configuration stuff that we would normally do. So now the app middleware is configured to use IMSAL to redeem the authorization code that's going to also ensure that the token cache has an entry for each user within the application. So I then went ahead and created a couple models similar to what we created in the previous project. So I have a category and a product. They mirror what we had before. And then in the controllers, I'm going to go in and I'm going to modify the categories controller object here. So in this categories controller object or controller class that we're defining here, I'm going to force people to be authenticated. But notice here that what we're going to do is I'm going to create this method here called getToken for user. This demonstrates how to use, let's go ahead and make you see the whole thing. This demonstrates how to use IMSAL to get a token. So here what we're doing here is I'm getting the current user object and tenant ID, and then I'm going to go ahead and fetch from the application. This application that's being passed in is, if I go up to the class for this, the constructor for this, you can see it's a confidential client application. So I'm using the ASP.NET Core dependency injection to get that value. And then, so here on the index page, I'm going to want to display all of the categories. And so here what I'm going to do is I'm going to go get the access token. I'm going to set up a HTTP client request. I'm going to set up his authorization request headers to use that bearer token. And then I'm going to call client.getStringAsync, or that's just going to fetch in that's going to fetch our URL to go make the request. So I'm going to go make the HTTP request to the category endpoint, getting this JSON. I'm then going to deserialize that into all of my categories. So that's my model I created. And then I'm going to add that to the view. And so if I go look at the view for my categories, my index view, all I'm doing is I'm going to be walking through all of the items in the model. And for each item in the model, I'm going to write out the ID and the name of the category. Products are going to work basically the exact same way, right? Or actually here, let me show you one more. On the create method, what's that going to do? So the create method, or the create view, is there's nothing really special with this. I mean, it's a standard form that's going to collect the name of the new category that you want to create. But what's interesting here is on the category controller, on the create method here, notice that I'm not doing anything related to any of the permissions related to the app. So it's a post, but I'm going to assume that the user has already been granted those permissions. When they logged in the first time, the app is going to request all the different scopes that we need for the application. And when those scopes are going to be requested, that's how we're going to be notified, or that's how we're going to get the user to consent to the different scope requests. All right, so now we're at the point where we can go ahead and we can spin up our web app. So there's one thing I do want to change with this before we do this though. So the first thing I want to change is if I come over here to our API, our web API project, inside of this launch configuration, if you think about it for a second, when ASP.NET Core launches a web app, be it a web API or a normal web app, it's going to launch it with two URLs, two default URLs. And it's set up to launch it with an HTTP URL on port 5000 and an HTTPS URL on port 5001. And that'll work just fine for one project, but when I try and start the second project, so if I do it for my web API project, it'll work just fine. If I try and do it for my web app project, that's going to cause a problem because those ports will already be bound to a running process. So what I'm going to do is I'm going to come over here to my ASP.NET API project. And I'm going to go into this environment variable and I'm going to configure a new environment variable for ASP.NET Core where I'm going to set the URLs, add a comma here, to HTTPS localhost 5050. That's the main URL that I want to hit, all right, for my web API project. Furthermore, this action that you see here, the server ready action, it's going to open up a browser and go navigate to this path. And this isn't what I want. I don't want to do that. So instead what I'm going to do is I'm going to go ahead and comment that out so that when I run this project, which I can do from going run and start without debugging, and that'll use this configuration, it'll spin up my web API project on HTTPS localhost 5050. Now, if I come back over here to my web project, there's something I want you to take notice of. If I look at my constants, first of all, notice there's my API. So I've got localhost on 5050. That's exactly what I want. If we look at my scopes, well, we'll see that I need to double check and make sure that this GUID is correct because this GUID right here is supposed to be the ID of my web API project, which if I come back over to my web API project and I look at the app settings, we can see that the tenant ID is something very different. So I'm going to go ahead and copy the client ID and I'm going to replace it on all 4 of these scopes that I've defined here. So these will be valid scopes. All right, so now I'll save my changes and now let's go launch this project. So I'm going to open it up in a console and say .NET build and followed by .NET run. Okay, so now my project is spinning up and it's now running on port 5001. So what I'm going to do is grab this URL and let's go back over to our browser. I'm currently logged in as Megan, so I'm just going to open up another tab so it's not going to force me to go back through all the login process. And it's going to take me straight over to the consent dialog. Now, I've never used my web app, so it's going to prompt me to go through the consent dialog. We see all the permissions that we defined. So there's our product read information, product write, product read, basic profile, maintain access. If I choose this checkbox, these values will change for whatever the administrative one was. Well, we didn't make a change there, except notice that write product category information is going to be there. So I'm going to go ahead and consent on behalf of the organization to give write access to this user, and then I'm going to say accept. Now, the write access is going to be for that category. Now from here, let's just go to our products page. So our products page is giving me a bunch of fake data. So here we can see all my data coming in for these different categories. If I choose if I go to the categories endpoint, we can see I have a categories endpoint. So in this demo, you learned how to create a server-side web app that enabled users to sign in and grant the app permissions to act on the user's behalf. And once the user has authenticated and granted the app consent to act on their behalf, the web app uses the data that's returned from a secure API by using the OAuth2 auth code grant flow. In this unit, you'll learn how to add an app role to an Azure AD application registration and consume a secured API from a daemon application. Apps that run without user interaction are referred to as services or daemon apps. A daemon is an application that runs, typically on a schedule, and doesn't require a user to be involved in the process. An administrator does need to go through a consent process to grant the daemon necessary permissions to call a web API. Unlike apps that have a user involved to implement the on behalf of flow, daemon apps implement the client credentials flow. Some examples of use cases for daemon apps include the following scenarios. Web applications that are used to provision or administer users to do batch processes in a directory. Desktop applications like a Windows service or on Windows or a daemon process on Linux. that can do batch jobs, or an operating system service that runs in the background. Web APIs that need to implement or manipulate directories are not specific users. There's another common case where non-daemon applications use client credentials. Even when a daemon does act on behalf of a user, the daemon needs to access a web API or a resource under their own identity for technical reasons. For example, access to secrets in an Azure Secure Vault, Azure Key Vault, or querying an Azure SQL database. Daemon applications, like applications that implement the on behalf of flow, are confidential client applications. And these apps, given that they access resources independently of users, need to prove their identity. They're also sensitive apps and must be approved by the Azure AD tenant admins. Now let's see how to create and configure a daemon app that can access a secured web API. The first step is to register a new Azure AD app in the Azure AD Admin Center that will represent the web application. The important part of the app registration is the creation of an app secret. This secret, along with the client ID of the app, is used by the daemon app to authenticate with Microsoft Identity when it requests an access token. It's important to use a certificate instead of a client secret when you're building production apps. Unlike web apps, a daemon app doesn't require a redirect URI. Daemon apps don't have a user experience, nor is a user involved. So there's no need to redirect a user to a web page. Now, daemon apps implement the OAuth 2 client credentials grant flow to obtain an access token from Microsoft Identity. And this flow permits a confidential client to use its own credentials to authenticate the app when calling an API. Your application can acquire a token to call a web API on behalf of itself, not on behalf of a user. And this scenario is useful for daemon applications. The first step an admin user must do is to grant the specified permission to the daemon app. Once the permissions have been granted via an admin consent experience, the app can request an access token. The daemon submits a request to the Azure AD token issuing endpoint and includes its client ID in secret or certificate. The next step is to create the daemon app that will obtain the access token and then access the secured web API. Create a new .NET Core console app using the following command, followed by installing a few NuGet packages to support Microsoft Identity. Now, update the project so it will authenticate with Microsoft Identity and obtain an access token. The scope to request for a client credential flow is the app ID followed by the /.default. This tells Azure AD to use the application level permissions declared statically during the app registration. The last step, add the code to call the web API. So here you can see we're issuing a request. We're first setting up the accept header to requesting application/JSON, and then we're adding an authorization header that includes the access token. And then finally, we're going to call the web endpoint. And we're going to do that by just calling the get async and pointing to the /API/categories endpoint. That will give me back a response that I can then parse out as JSON to display the results. In this last demo, we're going to learn how to add app roles or application permissions to an Azure AD application registration and consume a secured API from a daemon app. So we're going to first assume that you've already created, or that I've already created, the secure API app that I set up in the previous demo, in the very first demo in this module. We're gonna create a new Azure AD app and a new daemon app that's going to be able to consume that for us. So the first thing we want to do is I want to add app roles to an Azure AD application. So I'm going to go find my secure API, which we have here, my product catalog. I'm going to go to my project catalog API, and then I'm going to go down here to the manifest option. So in this manifest editor, what this is going to do is this is going to let me see the entire source of my my app that I want to modify. What I'm looking for is this section here for app roles. Where's app roles right here? And this is, I want to be able to define a new app role. So the app role that we're going to define, if I come over here, go ahead and paste it in. Let me explain what this is. So the member types, what this member types is, this is going to be set to an application. I then have a description set up for it. It's got a display name. So my display name is access as application. And then I need to define a GUID for this. So I need to be able to get a GUID and put a GUID in here for this application. So I'm going to go ahead and replace new GUID with a GUID. It's enabled, its origin is the application, and the value is as an application. It's important that the display name has no spaces in it as well. All right, now the next thing we need, we're going to save our API first. Now that that's done, so we have our app role, the next thing that I need is I need to create a new application here, new app registration for my daemon or for my service app. So I'm going to call this the product catalog daemon, and I'm going to make it be a single tenant as well. Now we're going to need these two IDs. We'll come back and get those in just a few minutes. Before we do that though, I'm going to need the certificates and secrets. Go ahead and create that first. So let's go ahead and let's create a new secret. And I'll say, go ahead and add the secret. And let's just go ahead and copy this. So what I'm going to do is let's go put this, open up VS Code, and let's put some of this stuff in a little scratch pad. So the first one is going to be my tenant ID, and then I have my client ID. Let's go grab those from our app that we just created. So we have our directory ID is the tenant ID, and the client ID is like that. And then the secret is right here. Okay. Now, the next thing we need to do is we need to grant the app permissions to call the web API. The permission is requested in the same manner as the Microsoft provided APIs as in the Azure AD portal. So I'm going to come over to, in my application here, I'm going to pick API permissions, and I'm going to add a permission. So I need to then find my app. So my apps my organization uses. So here we go. Let's do my APIs. There we go. There's the one we just created. So I'll select this. I'll then pick an application permission, and I'm going to pick the role or the application permission that we just defined a moment ago. So I'm going to go ahead and select that permission. So then I'll go ahead and say add permissions. So when it's added here as an application, what I'm going to have to do is I need to grant it. So right now it's not granted. So I'm going to go in and say grant consent for Contoso, grant admin consent. And what this is going to do is it's going to go ahead and grant consent to those different permission requests. Now I can do that because I am a tenant administrator. Now that we've done this, we're all ready to go. So let's go over and look at our console application. My console application that we've created here, here it is our program here. And all this is going to do is it's setting up all of the authentication stuff that is going to be needed to be able to connect to our app. So it needs to load in the settings, which actually let's go ahead and let's go update our settings. So here's app settings. We need the tenant ID, which is this value. We need the client ID. And we need the client secret. Now the last thing we're going to need here is if you notice, first of all, we have our API base addresses set up, so that's correct. That's still what we want to use. But I also have to define the API scope. And so what I need to do with this value right here is I need to go get the ID from my secure API. So let's come over here to secure API, And let's grab the client ID for that one. So again, this is similar to what we had to do in our web app, where we have to tell it what are the API scopes that we want to be able to use. All right, so let's go back and let's look at the code for this. So first of all, before we look at the program, let's look at the authentication configuration. So what this file is going to do is it's got a couple different properties that are defined, but then inside of it as well is it's going to be using the app settings file to go through and deserialize everything, which is what's setting all of these different values on our application. Notice too, if I go back to our app settings, notice that the API scope is set to the .default scope. Now what that does is that says I only want to get all of the scopes that have been defined on this API and that have been consented to. So I will get all of those different permissions listed here. And in this case, we only had two. We had like user read and access as an application. Now, a little bit farther down in program.cs, let's look at this code. So we are loading our settings, and then I'm creating a confidential client application, which is using our ID, our secret, and the authority that we are loading in. The next thing we're doing is it's going to go set up the code that we have here. Where is it? There's our main method. So here it's going to run async and call the get result. So let's see how this works. So if I come down here to our method of get result, wait, no, sorry, not get result. Let's say it again. So our main method is going to call the get async. So let's go look at the get async. This is what we were just looking at a moment ago. So after we set up our client configuration, we're then going to get a request for the scope that we're going to be requesting. So this is going to be requesting all the permissions from our API. I'm then going to use my confidential client to acquire a token for the client using those scopes to get our request back, and it's going to display our access token, or it's going to show us that we've received our access token. After that happens, assuming that we got our token, which is this right here, it's then going to use the HTTP client and then set up the headers to include that authorization header. And it's also going to specify the data we want to get back as application/JSON. So there's our accept header is coming back as application/JSON. Here's our authorization header that's going to use the access token. And then here it's going to list out all of the categories. So it's going to issue a request to say, go to the client and issue a request to our base API/categories to get all the categories, and then it's just going to read it in and then parse out the results and then write the results out using a display method that's defined a little bit farther down. So everything is good to go with one exception. The one thing that we're going to also need to do is we're going to need to create a new endpoint here for our categories for getting all of the categories. So what I want to do is let's come back over here to our API and let's open up the categories controller and let's find the part where we're doing this get all categories. So what I want to do is I want to modify this get all categories. We want to make sure that if the user is accessing it as an application, that it will allow us to go retrieve all of the different categories and make sure that they have the correct scope. This is only going to be checked if the application has this access role. So what I'm going to do is come in here and say if HTTP context dot user is in role access as application, then make sure that it has the categories, the category.read permission, and then it will go through and return those categories. So now we can start this up. So I'll start up my API project again. All right, and now come over to our console app and let's go ahead and spin this up. So let's test our app by doing a .NET build and a .NET run. And we're getting an error here that our tenant was not found, and somehow we screwed up our tenant. We overwrote that. So this is what we wanted to use. We wanted to use this for a tenant ID. Just mistype that. This will be an easy fix. .NET run. There we go. So we saw the results that came back. So we can see that when it ran, it told us that it acquired a token, and then it wrote out all the categories for our category API. And so in this exercise, you learn how to add app roles to an Azure AD application registration and consume a secured API from the daemon app. Thank you for watching this module. I hope you got a lot out of this, and I hope you learned something. This screencast is has an associated module to go along with it. And that module includes not only slides and demos, but it also includes a hands-on lab that will walk you through all of the steps that we showed here in the demonstration sections of this screencast. So make sure you check out the notes for this video to get access to the module where you'll find more information that you can use to get more about these resources. Thank you very much.